In this section, we're going to look at converting from rectangular equations to polar equations, or from polar equations to rectangular equations. First, we're going to look at converting from rectangular to polar. Now, to convert from rectangular equations to polar equations, we use a substitution x is equal to r cosine theta and y is equal to r sine theta. And we also know that x squared plus y squared is equal to r squared. Here we have three examples. The first example, we have x squared plus y squared is equal to 16. We know x squared plus y squared is equal to r squared, so we can rewrite this as r squared is equal to 16. Therefore, r is equal to 4. So here we just converted this rectangular equation to a polar form. In this one, we have y is equal to x. We know y is equal to r sine theta, and that x is equal to r cosine of theta. If we divide both sides by r and divide by sine theta or cosine theta, this cancels out, so we're left with 1 is equal to tan theta. So theta is a tan inverse of 1, so theta is equal to pi over 4. Here, for y is equal to 1, we know y is equal to r sine theta is equal to 1. If we divide both sides by sine theta, we have r is equal to cosecant theta. So here's our polar form for this rectangular equation. Here we have two additional examples of converting from rectangular equations to polar form. The first example is 3x plus 5y minus 2 is equal to 0. We know that x is equal to r cosine theta, so we can substitute for x. We know y is equal to r sine theta, so we can substitute for y. So here we have 3r cosine theta plus 5r sine theta minus 2 is equal to 0. Now here's just a matter of solving for r. If we add 2 to both sides, then we have 3r cosine theta plus 5r sine theta is equal to 2. Now we can factor r from both of these terms, which gives us r times 3 cosine theta plus 5 sine theta is equal to 2. And if we divide both sides by 3 cosine theta plus 5 sine theta, we get r by itself, which is 2 over 3 cosine theta plus 5 sine theta. In our second example, it's a little more challenging. We have x squared plus y squared all squared is equal to 9 times x squared minus y squared. This is x squared plus y squared, which we know is equal to r squared. So if we replace all this with r squared, we have r squared squared, which gives us r to the 4th power. We know x is equal to r cosine theta. So since this is x squared, then that will give us r squared cosine theta squared, or cosine squared theta. Y is equal to r sine theta. So if y is being squared, that means it's r squared sine squared theta. If we simplify this and factor out the r squared, we now have 9r squared times cosine squared theta minus sine squared theta in the parentheses. We know that cosine squared theta minus sine squared theta is one of our double angle identities. It's actually equal to cosine of 2 theta. So instead of all of this, we write cosine of 2 theta. So now we have r to the 4th power is equal to 9r squared cosine 2 theta. Dividing both sides by r squared, we end up with r squared equal in 9 cosine 2 theta. Here we have two examples of converting polar equations to rectangular equations. In the first one, we have r is equal to 2 cosine theta. And in the second one, we have r is equal to 10. Now in both equations, we have the equations written in terms of r. When an equation is written in terms of r, the easiest way to rewrite these is to make r squared. Here, to make r squared, we can multiply both sides by r. So if we distribute r, this becomes r squared is equal to 2r cosine theta. We know r squared is equal to x squared plus y squared. And we know that r cosine theta is equal to x, so this becomes 2x. If we subtract 2x from both sides, we get x squared plus y squared minus 2x is equal to 0. So here I've converted this polar equation to a rectangular equation. To make this r squared, we could square each side of the equation. So instead of multiplying both sides by r, another option is to square both sides. So here if we square r and we square 10, this becomes r squared is equal to 100. Once again, we want r squared is equal to x squared plus y squared, which is equal to 100. So here we have our rectangular equation for this polar equation. Here are two additional examples of converting polar equations to a rectangular form. This time we're given a polar equation in terms of theta. Here theta is equal to 5 pi over 6. If we take the tangent of both sides, we get tan theta on this side, and we know tan theta is equal to sine theta over cosine theta. So the sine of 5 pi over 6 is 1/2, and the cosine of 5 pi over 6 is a negative square root of 3 over 2. If we simplify this, this becomes negative 1 over the square root of 3. Rationalizing the denominator, we multiply by the square root of 3, the square root of 3, we end up with a negative square root of 3 over 3. We also know that tan theta is equal to y over x. Multiplying both sides by x, we end up with y is equal to negative square root of 3 over 3 times x as our rectangular equation. In this problem, we're given r is equal to 2 cosecant theta. By dividing both sides by cosecant theta, we end up with 2 on this side. So this becomes r over cosecant theta. We know the inverse of cosecant is sine, so this becomes r sine theta. R sine theta, we know, is equal to y, so this in our rectangular form is simply y is equal to 2. Here we have an additional example of converting a polar equation to a rectangular form. Our example is r squared is equal to cosine of 2 theta. We know from our double angle identity that the cosine of 2 theta is equal to cosine squared theta minus sine squared theta. So now we have r squared is equal to cosine squared theta minus sine squared theta. We know cosine is equal to the adjacent over the hypotenuse. So this would be x over r, and we know that sine is equal to y over r. So substituting for cosine theta and sine theta, cosine theta becomes x over r squared minus sine theta, which is y over r squared. So this gives us r squared is equal to x squared over r squared minus y squared over r squared. Now if we multiply both sides by r squared, this becomes r to the 4th is equal to x squared minus y squared. R to the 4th is the same thing as r squared squared. X squared minus y squared. We know r squared is equal to x squared plus y squared. So replacing r squared with x squared plus y squared, we have x squared plus y squared all squared is equal to x squared minus y squared. So here I've converted this polar equation to its rectangular form.